Hello, a very good day to all students who will be sitting SPM next year on February. Okay, this module is especially for those who will be sitting for the new practical test in paper 3, which is introduced again since 1998. However, due to the time constraints, okay, the content inside will focus on few important apparatus which you will may encounter in almost every experiment. Also, a few important manipulative skills will also be introduced to you. I hope that this module will help you a little bit while facing the SPM practical test. Now, the contents for Module 3 were divided into 4 sessions. First, the introduction to basic measuring instrument, and number 2, there is some selected experiment and also the importance procedure to carry out the experiment. And session 3 will be important aspect, how to process the data which you obtain from an experiment. And the last part, there will be exercises given to you, 2 questions, and you will need to solve it in 40 minutes. Now, the basic measuring apparatus which you always encounter one will be meter, ruler. Stopwatch will be divided into a digital or mechanical, battery holders, ammeter, voltmeter, and also one of your not frequently seen friends, that is the Rheostat. All this you need to master it to face the possible questions coming out from the practical. For meter ruler and also half meter ruler, this is the most basic measuring instrument for length. And now there is one precaution here. Before using it, try to check both scale, okay, at both ends, okay, of the ruler to measure them they are in good condition. If it is not very clear or the scale is lost, please ask the supervisor to change it. Now, the smallest deviation for this ruler is 0.1 centimeter or 1 millimeter. So please measure that when you write in the table. Next session, when the pictures appear, I think you know already. This is a stopwatch digital. Now, try to watch the video for the operating procedure. First, start and stop, and then the last one, you need to reset back. Try to practice a few times so that you can get used to it then before you start to using it. Now, this is the antique type of stopwatch, a mechanical one. Okay, to start with, just press it. And then if you want to stop it, press again. And you want to reset it, press again. Just press and press and press. Right now, sometimes the mechanical stopwatch will have a little bit problems. Okay, it will stop in the middle somewhere while you are recording the time. So to prevent this, you try to let the stopwatch run for a few rounds on the second pointer. The second pointer to make sure that it is not start. If it is started, then twist the button at the top. It can be twisted, but not too many rounds. Only 2 or 3 rounds is enough. If the condition still appears, it is operating it, it gets start. So you ask the supervisor for changing it. Next, a very important apparatus in electric experiment, that is battery holders. We have now normally in almost all school lab, you have 2 types of battery holder. The old one, okay, normally is in one bundle, cannot be separated out. The connection mode normally is in series. Okay, the latest one, the middle diagram and also the right diagram. This one is just a Lego, can be separated out according to the need of experiment. Okay, it can be arranged either in series, that is on the right diagram, and also parallelly in the middle diagram. Now, the emitter. Emitter, you know that it is an instrument to measure electric current. So before using emitter, make sure the pointer is exactly on the 0 scale. If it is not really exactly at the position of the 0 scale, then use a screwdriver to adjust it. Or if your fingers nail is strong enough, you can use it as a screwdriver. Now, emitter is a very important instrument, and you need to make sure that it is connected series. That is very important here. Another one is to measure the potential difference across an electric appliance. For example, a resistor, maybe a constant wire, and some other important electrical appliance. So the voltmeter is the same also. You need to connect it difference for emitter that is in parallel. If you connect it in series, that means the voltmeter will malfunction. Try to read the notes inside the hangout given. Some of the slides might be a little bit longer. It is to help you to record down the important notes. So please take note of it. Now, this is among the one most alien electrical apparatus for view, the rheostat. So the rheostat normally is aimed to control the current in a circuit. Okay, the important parts are the wiper or the slider and also the coil. There are 2 kinds of connection as shown in figure. So each of it can be used, determined by yourself. Okay, if you like the first one, use it, or second one, but you see better, so you can also use it. Now, give you some information how's the currents flow in a rheostat. So just watch the arrow here. If you connect like this way, the first diagram here, current will flow from the red crocodile clip to the wiper and go down through the coil and then come out to the negative terminal. Another one, if I connect like in diagram 2, it will go inside again, okay, from the positive terminal to the wiper to the coil and then out to another negative terminal there. Okay, try to see the notes for further information. Dear student, if you want to take a snapshot, also can. It is the fastest way for you to get the information down rather than you copy half that. So I purposely made the slide a little bit longer, started in somewhere for some of the important parts, just to let you have a chance to copy it down. Now we come to section number 2. That is 3. Select the experiment. Simple pendulums. Ohm's law, that is the relation between the potential difference across an conductor and also the currents flow through it. And also the last one will be EMF and also internal resistance for a cell. How to measure it. Now, the simple pendulum. Material apparatus is simple, among the simplest throughout your experiment. Then you need first the rheostat and clamp, stopwatch, either mechanical or electrical will do, meter ruler, pendulum board, and rubber cord you carved into half. And the last one will be a thread around 110 centimeter long, or you can make it shorter a little bit, around 100 centimeter is alright. Now we go to the procedure of experiment for this simple pendulum. So you try to set out the experiment as shown in the diagram there. Tie the provided pendulum with a given thread. Okay, now you displace a little bit force and release it only. So make sure the angle of displacement is not more than 5 degrees. Okay, you can start with the length you selected. It's not necessary it's 80 centimeter, but you can start with 70 centimeter or 60 centimeter. And then you need to record the time taken for 10 or 20 oscillations. It depends on your on the instruction given. It might be 10 or 20 oscillation. Now the period of oscillation is calculated according to the equation t is equal to small t divided by 10. Remember, the most important safety precaution is you try to make the angle of displacement small. Now the process will be repeated for another 4 data. Okay, that's manipulative data. That is around the length is 70.0 centimeter, 60.0 centimeter, 15.0 centimeter, and 40.0 centimeter. After you gathered all the information, you need to tabulate all the values for L, not M here, sorry, for the wrong typing, L, T, capital T, and then T square. So a graph of T square versus L is plotted. Now you will see that this experiment manipulated variable will be your length of the pendulum, the responding variable will be period of oscillation, and the constant variable is gravitational acceleration g. Now some precautions stage. The length of the pendulum is calculated from the center of the pendulum border. Besides, another precaution that already add in the front, that is the angle of displacement must be small, if better smaller than 5 degrees. Don't worry that the pendulum will stop, but if the angle is too small, you let it for a day or overnight, it's still swinging there. So don't worry about that. So remember, the length is measured from the center of the board to the length you want, not measure the length of the thread. Here I insert a video clip just for a few seconds to let you know how small the displacement you need to adjust. Well, the length here I think is around 80. So please be very careful when you start the oscillation. Now another one very important aspect is that while the pendulum is swinging, especially the longer length, 80, 70, and so on, you need to make sure that the board oscillate in one straight line. Oh, the line is missing. Never mind. I hope everyone okay with this. So if you find that the board is circling in a cone shape, so please stop it and restart the oscillation. So the expected result will be the graph t squared versus L is a straight line through the origin. Or you can say t squared is directly proportional to L. Next, we have experiment number 2, an electric experiment, that is to find the relationship between potential difference across a conductor to the electric current flows through it. And normally we call it as Ohm's law. Now, you have given the following apparatus. There is 3 dry cells. Number of dry cells depends on questions. Battery or cell, and also cell holder, ammeter, voltmeter, rheostat, 20 cm long consonant wire SWG32, 7 to 8 connecting wires, okay, and then a switch. Now, here I insert the methods for you to connect the circuit efficiently. First thing, battery as a sources. So it is first thing you need to insert the battery inside the battery holders or cell holders. Then you can start clockwise or anti-clockwise direction. Okay, let's say anti-clockwise direction, you start with rheostat, and then you connect to the constant wire SW32, which are labeled as white line. It is not very clear in the pictures. Okay, then you go to the emitter. Remember that the emitter negative side and positive side is very important. The terminals of positive and negative. Make sure that you connect it correctly. Okay, next, the last thing you insert will be a voltmeter. You click to the constant wire. You also need to adjust the rheostat first. When you first plug in the emitter, you need to find out the maximum and minimum current obtained. Determine a suitable value for the current I to manipulate. While waiting for the slide to change to another page, you try to copy down the procedure here. This is very important for the guidelines in the electricity. Almost all the electricity experiment, you need to follow this for SPN syllabus. I repeat again, follow the left diagram, okay? Using battery as the reference, you start with either the voltmeter, the emitter or the rheostat, okay? So you connect a circle like this, adjust the value of I, see which is the maximum value of current can be achieved for the circuit, and also the minimum current that can be achieved by the circuit. Okay, then you choose 5 suitable manipulated data of I. Next, after that, you connect the voltmeter parallelly to the constant wire. That is the last step you do. So don't be confused while you're doing the electricity experiment. Now again, some very important precautions there in Ohm's law experiment. So the first thing, make sure that all the connection points are tight, especially the constant wire. Sometimes the question will instead using the resistor, which is better than constant wire to click off, but just make sure that all the connection points are tight. If you see your ammeter or voltmeter reading is not stable, then there must be something wrong with the connection. Number 2 is the most important one. After taking every reading, you need to switch off the circuit. Let the constant wire to rest down so that the heat inside the constant wire will be vaporized. Otherwise, the result you get later on will not obey the Ohm's law theories. Okay. Another one, if you are using anything's measurements instrument, there is always a very standard procedure there you can write. Okay. That is the eyes of observer should perpendicular to the scale of voltmeter and ammeter. Now next we go to the variable in the experiment. The manipulative variables will be your electric current, responding variable will be a potential difference, and the constant variable, the most important one, will be temperature of constant wire, SWG22, or if you're using a standard resistor, you can write the standard temperature of a standard resistor. There are others also, the some constant variables which you can write also, but the most important one will be the temperature. Other constant variable, for example, like the length of the constant wire, the resistivity of the constant wire also can be counted, but it is not in your syllabus, so don't write it. Okay, just the temperature of constant wire is the most important one. So expect the result, you will get a graph V versus I, which is a straight line passed through the origin. Gradient of the graph will represent the resistance of the constant wire. Now we go to experiment number 3. That is experiment to determine an EMF, that is electric motive force, and also the internal resistance of a given cell or a cells, okay, a group of cells in series. The apparatus and material for the experiment will be, it's almost the same with the Ohm's law experiment. You have 3 dry cells, battery or cells holder, ammeter, voltmeter, rheostat, also 20 cm constant wire SW32. Okay, you can use SWG28 also can, but the resistance I think is your voltmeter reading here will getting smaller. Now the connecting wires the same, 8 connecting wires, or sometimes 7 is enough also. And the switch, the last one. Next, we go to the procedure. It's the same, but watch out. Did you notice that the voltmeters now is no more at the constant wire side? It is moved to the battery. And it's connected parallel to the battery. The procedure is more or less the same. So the first thing, for the first diagram on the left, you connect the circuit, okay? Adjust the rheostat to find the maximum and minimum current which can be obtained and determine suitable value for the current I to manipulate. That is 5 manipulate variables, okay? And then you connect the voltmeter parallel to the batteries, okay? So then you start the experiment with 5 different values of I, okay? The corresponding values for potential difference are recorded. Now, some important precaution steps in the experiment. So first thing, again, same with the Ohm's law experiment, make sure all the connecting points are tight. Again, the temperature of the constant wire need to be maintained. Actually, it's the temperature for all the how to say it, all the electric appliances in the circuit, including voltmeter, ammeter, and so on. You need to maintain it to a stable conditions. So switch off the circuit means that to cool down the circuit. And also because you have voltmeter and ammeter, so the eyes of observer should perpendicular to the scale of voltmeter and ammeter. So the variable in the experiment, manipulated variable is electric current, responding variable, potential difference, constant variable here, a little bit more than the Ohm's law. You can write that is temperature. The most important thing, I think you still need to write temperature of constant wire, SWG32, EMF for dry cell, and internal resistance of the cell. So the expected result will be a graph decreased linearly. And the gradient of the graph is the internal resistance of cells. Now we go to data processing in session there. After you gather all the information, the data, manipulate variables, and also responding variable, now you need to first thing tabulate the data in a table. Now, the data can be divided the primary, secondary, or even you got tertiary data according to the process. So primary data is the first-hand data recorded from the measuring instrument. The decimal points must follow the accuracy of the measuring instrument. That is the smallest value or smallest division from the data. Remember this? So in SPN, normally vertical form of table is used to record the data. Okay, so the following procedure, you must follow it. Start with primary manipulated variable and responding variables. Then it is followed by secondary manipulated variables and secondary responding variables. You need to refer to the table which I inserted here. So the primary data will be your object distance and image distance. This is the experiment object, whereas the secondary manipulated variable is your 1 over U, and the 1 over V is the secondary responding variable. Now we go to the graph plotting techniques. How to plot a nice graph or a good graph. First thing, observe carefully the responding variables at y-axis and the manipulated variable x-axis value range. Choose the suitable scale. That is the most important one. So you graph area to cover at least 70% of the area in the graph paper. The colored area normally is green or blue in color. So here are some suitable ratio of scale. That is 1 cm to 1, 1 cm to 2, and 1 cm to 5. Okay, this is done so that other person who read your scale can find the value easily. So avoid using some odd scale which cannot give you an accurate number. For example, 1 over 3, 1 over 6, etc. Also, you need to know that you need to label your axis with the names of relevant physical quantity inside. For example, just now the table is your object distance and image distance. So the secondary one will be 1 over U and 1 over V. So the y-axis will be your 1 over V and x-axis is 1 over U. And also, not to forget, write down their physical quantities unit. That is per centimeter. Another important aspect is the number in the axis, on the axis, you need a suitable decimal point. That is the smallest value that can read from your axis scale. Now the last thing is that all the points for your reading need to mark with a cross. Okay, don't use dot. Okay, the cross also cannot be too big or too small. Normally it just size around 2 millimeter. Is the size of smallest partition you can get from a graph. Now, of course, the last thing, you draw the best fit line. So the next slide, I will show you how to do the best fit line. Now, this is an example also experiment. Now you see on the table there are two naughty points, and most of you will get fed out when you see the line like this. So if you connect all the points, it is just like a red line. It's not a straight line. So how to do it? We know that the Ohm's law said that V is directly proportional to I. So the line should be start from origin. So you make sure that the line is not connected all points, but pass through all points like in the blue line there. So just make sure that. Dear students, you can copy down this. I don't know how many of you know how to draw the best fit line during the experiment. So try to have get a chance to study it. Yeah? Alright, class. This is the last session for the module. Go to the following site and find the questions to do. After finishing it, then you refer to the answers given. However, I didn't provide all the answers to you. Some part I just dismiss it. Only for the table and graph and some of the necessary readings, I will provide with answers. Okay, thanks for watching this video, and I hope that this module will help you at least a little bit to enrich your knowledge in the practical.